Hello everyone, welcome to LeetCode walkthrough series. Today we are going to solve sort colors problem. The problem says, given an array nums with n objects colored red, white or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white and blue. Okay. So they've given an input array called nums that has values 0s, 1s and 2s. They represent these three colors. So 1 represent red, 0 represent red, 1 is white, 2 as blue. Okay. Let's take this example. Okay. Now we need to make sure all zeros come at the start position and all 1 comes next to them and all 2 comes at the end adjacently. Now to solve this problem there are two approaches. One is counting sort approach using counting sort, and here we're not going to use any library sort function. Python has this built-in sort function, we're not going to use that. Okay, so counting sort approach, this takes two passes. In first pass we iterate over entire array and count number of zeros, number of ones and number of twos. Okay, after counting, store each of the count value in three separate individual variables. Let's say for storing zeros count we use red count variable, and for storing ones count we use white count variable count, and finally use blue count for storing twos count variable. And in second pass we take result list and result array list and store all these values by decrementing each of the respective counts. Like zeros count, firstly append zeros by decrementing red count variable, and append ones by decrementing white count variable, and finally append twos by decrementing blue count variable. So this method works, that's fine. It's order of n time complexity, but it takes two passes, that's one thing, and it takes an extra order of n memory for storing the result here, result list. So there is a better approach to solve this, that's called as Dutch national flag approach, DNF approach. Okay, it takes three pointers, let's say left, left and right. Okay, so to help you better understand this, we do this, let me show you this in the whiteboard. So the pointer I and left, let's call it as L, and R points in these positions. I and L points at the starting position and R points at the ending position. Now the algorithm looks like this. Whenever nums of I encounters 0th value, we swap the value with the value of L, okay, nums of L, and increment both L and I pointers, left plus plus and I plus plus. Now whenever nums of I encounters a value of 1, we just increment the ith value, ith pointer value, and finally whenever nums of I encounters 2, value of 2, we swap the value with nums of right pointer value. I'm just indicating L as left and R as right. Okay, you can understand that way. So after swapping, decrementing the right pointer, we decrement the right pointer, or minus minus, so that it squeezes inwards. You will see in the end we will have the array where the red colors comes first, zeros, and white comes in the middle and blues at the end, 0, 1, 2. Okay, all arranged in the adjacent fashion. So let's do the dry run. Now I is pointing at the 2, so we swap the value with the last R right pointer, so we swap it here. Okay, and this becomes 1 and this becomes 2, and we decrement R pointer here. Okay, R is pointing to the 0th value. Now in the next iteration, I is 1, still 1, so just increment the ith pointer value to the next position to here. Okay, now I is still 1, just go to the next position. Okay, let me correct this. Yeah, so now I is 2, swap this again with the right pointer. Let me do this way, better go this way. Here this becomes 2 and this becomes 0, and after swapping, move the right pointer inwards. Okay, and let's let I be in the same position. Now I is becomes 0, swap this value with the L value here, swap it. Now this goes this 1, now this becomes 0, and increment both L and left pointer and I pointer. Okay, now I becomes 0, again swap the value with the left pointer. And increment both of the left and right pointers. Okay, now I is 1, don't do anything, just move on. I is 1, move on. Now I is 0, again swap the value with the left pointer, current left pointer here. This becomes 0 and this becomes 1, and move pointers L and R, L and I. L and I goes here. Now I is 1, don't do anything, just move on. I goes here. So now I is 0, and we know that we have to swap this with L pointer, left pointer, sorry, goes here. Okay, now take this here. Okay, this becomes 0, and finally this becomes 1. Now the ending condition is when I and R are equal. As you see now they are equal, we need to check that. Let me write that condition down. We need to iterate entire loop inside the while loop. When I is less than or equal to right pointer, just writing it as here, we have to break the loop. So I equals to R pointer, they are pointing. One last time it checks. I equals to 1 value, so it increments and the loop gets over. So the loop has to terminate when I comes next position to the rth position. So you can see now the end result, all zeros are sorted here and all ones are sorted in between, and finally we have all twos are sorted at the end. So this is the DNF approach. So let's go back and copy this and go back to our LeetCode. Let me copy this. Okay, for your reference. Okay. Now algorithm. Okay. Algorithm. Okay. This is while loop here. I missed it. Let's add it. Okay. The while loop comes here, while I is not equal to right pointer. Okay, I'm just beautifying things. Okay, now let's code the solution. So we initialize I and left to 0, okay, and right pointer to the end value, len of nums of equal to -1. Now while I is less than or equal to right pointer, here we need to check if nums of I equals to 0, first condition. If this is the case, swap the nums of I value with the nums of left. Okay, and increment both left and I value. Next, else if that's not the case, nums of I equals to 1, then just increment the ith value. If both are not the case, and obviously the other number is 2, so it goes to else condition. Else swap the it will be value 2, so swap that value with the nums of I with the right pointer value. Okay, nums of I and decrement the right pointer. Okay, so let's see if this works. This is the code. Let's run this. Oh, okay, sorry, I made a mistake here. So we have an index I. Let me check, where did I go wrong? I'm so fine. Oh, my bad. I have to decrement here. Sorry for that. So let's run this. R goes inwards. Okay, the solution works. Let me submit it. Okay, the solution is accepted. Now let's discuss time complexity. So at least one of the pointer runs throughout the array, entire array. So the time complexity is order of n in the worst case. So at least one of them, either I iterates from left to right, or R iterates from right to left, leaving one position at the last, or L iterates from again left to right. So that space complexity is, since we are doing this on a single array, we're not taking any extra space here apart from these variables left, right and I. We're doing in place, so it's order of 1, no extra space needed. So that's all the solution is. So thanks for watching.